Good afternoon, everyone. Good afternoon, everyone. Am I audible?
Yes, sir, audible.
Thank you, ma'am. I welcome you all back to the next session. So this session will be handled by Sri K. Balachodappa. So Sri K. Balachodappa is working as an assistant professor in CSE department, G. Pulla Reddy Engineering College, Kurnool. He did his BTech from SVSET, Chittoor, and MTech from Intel College of Engineering, Anantapur. He have 12 years of teaching experience. So now he is going to handle the session on practical approach using NLP. So with this brief introduction, I request Sri K. Balachodappa sir to take over the session. Thank you.
Thank you, Suresh, for introducing me. Is my screen visible, Suresh?
Sir, 1 second. Sir, please share your screen, sir.
Yes. I shared it. Is it visible now?
Yes, sir. Now it's visible.
Okay, thank you, Suresh, for introducing me. Good afternoon to all the participants. Welcome to this FDP program on natural language processing. Today, I would like to present the basic concepts regarding NLP, and most of the research is going on NLP and what topics that we should be familiar before we are moving to NLP research work and all. And this is the main agenda of my today's session. So I will go with definition, NLP in machine learning on text, NLTK demo, how good and how bad NLTK, and conclusion remarks. So far, whatever in machine learning we have been studied about the supervised and unsupervised. NLP is also a part of AI. So what can we do with the NLP in the sense?
Chodappa sir?
Yes, sir.
I can please press F5 or full screen mode. Full screen mode. Full screen mode.
Full screen mode. Yes, I clicked on it, sir. Is it okay now, sir?
Yes, sir.
Yes, now it's okay.
Yes, thank you, sir. So NLP is a part of AI. So and this NLP, what it will do means it will do some automatic manipulations with that of our natural languages using some text and speech by means of some programming languages. Right. So here, so what a natural language will define you means it will define you the way the human will communicate with each other. So in the similar manner, the machines are about to communicate with the human beings, and it will respond to the questions and the responses. Like we are daily seeing in our chatbot, right, where we are asking some questions, and the machines will interact the proper responses to the questions that are asked by the users. So normally nowadays we are totally surrounded by the text. So how can we make use of this text for performing some calculations using some particular kind of softwares like Python and all? So that's what we are about to say in this. So coming to NLP in machine learning, it is also playing a major role in AI. So when we are interacting with AI, so it will tell you how the machines will interact with the human beings and all. And moreoverly, this NLP also will make use of so many machine learning algorithms. It will train its best, and it will give you the experiences what it learned from the training data set, and it will tends to give the results what it understands. So here, so using NLP also we can able to do it on machine learning and all. So coming to text, when we want to do some machine learning on text, the most why, because as defined in the definition, so NLP totally concerns with the text and speech. So we are about to talk about on text. So how this textual informations can be get trained by the machines, and what kind of machine learning algorithms that we can apply on this text for having some better results. So what can we do? So we can go in detail now. So when we are working with a text, we need to consider some basic building blocks. For example, say if I have some data set like numerical data sets and all, we can directly apply the classifier on the numerical data set, and we will train the machine. Once we trained it, we are about to test it whether my model is good or not, right? Or otherwise it is giving good accuracy or not. When in contrast with that numerical perspective, when we comes with some textual perspective, here we will call those instances as some documents. In normal data sets, we will call instances. So that instances in NLP, we are calling it as document. So when we talk about document, means it doesn't matter about their sizes. So it can be a big corpus, a collection of documents. It can be the textual data, or it can be some emails, whatever it may be. So it doesn't matter about their sizes. It will consider instances as some documents. So when we are in NLP, we should treat each and every instance as one document, and this document is full featured with some text. Right. So, and moreover, one more building block we normally used in NLP is called as a corpus. It is just like a collection of documents. These documents, some are labeled or unlabeled, whatever it may be. So it is a collection of so many documents, and these collections of documents can be used in NL to train a machine. And one more building block that we use is the features. So the same thing, we normally know what features are in a data set. Features sometimes we will call as some attributes and the columns and all. So, but in NLP, when we come to the perspective of these features, so this plays a vital important. For example, if we plot if you plot the features of a particular data set on some feature space, we will find features like this. That means these features can occupy their spaces in some n dimensions. It can't be some one dimensional or two dimensional or some three dimensional. It can be scattered across the feature space. And so if I want to consider what kind of dimensional space it is very hard to define it as because it is n dimensionally occupied, and moreover your features are well spread over your feature space. So treating the most important features is a major task in NLP. So like this, you may find features across over your dimensional space. And moreover, document. When we consider document, whenever we use the word document, a document normally consists these things, right? So it is a collection of some paragraphs, sentences, and tokens. And moreoverly, when we consider a particular document, what features that we should consider means normally these features can be at the document level or at the word level. Anything we can be make use for training our machines, but at the document level, the features that we considered are nothing but the metadata. For example, say if my data set having a set of attributes like title, author name, text, label, unlabeled data, whatever it may be, a collection of some features. So that metadata we can consider that metadata or the paragraphs or the sentences, so that the document at the document level, these things will be considered as the major features. But when we consider at the word level, we will consider vocabulary and frequency, forms, tokens. So we will use some alias names for tokens and all. All right. So these two can be considered as the most important features for a particular document. But when we are trying to train some particular machine, what kind of features we are selecting, that is most important, either at the document level or at the word level. So that should be taken care into the considerations. So we will see all these things using some NLTK demo. So working with the text, I plan to work with some text. So in this NLTK demo, I will work with some particular data set, do some data pre-processing and using some feature extraction techniques model and using some classifiers that will work on the text to predicting how good it is. So when working with, we will come up with the first thing, working with the text. So when we are working with the text data set, so for the first and foremost thing is we need to focus on this. First of all, ensure that our text will be converted into the lowercase or the single case, and if any numbers will be there, that has to be removed, and if numbers will be there, that has to be converted into words, and if any special symbols or punctuations like white spaces or whatever it may be that is containing in your textual data set, these things has to be first eliminated before. So these things we are about to do in the data pre-processing. So for example, how can we understand means, for example, if you consider that this is just a string, but you assume that it is some document, and the document will containing a text like this. When it have a text like this, first of all, ensure that whether my text containing some capital letters or not. If it is there, I need to be converted into some smaller case like this. Right, so this is how the way we can do in small lowercase, and if we have some numbers and all, we need to remove it. For example, there are 3 balls. This 3 has to be get removed, and 12 these numbers has to be get removed. And if there are if there is a requirement for number also, then we need to convert that number into words in terms of some pre-processing. And moreover, any special symbols, if I have like single quotes, double quotes, comma, and what NLTK mostly come up with the punctuation symbols and all, we will come to know it. So those symbols, if it is present in my document, those things has to be get removed. So that is the main intention behind doing all this pre-processing before we are feeding that features as an input to some machine learning algorithms. And moreover, white spaces, if we have, we need to remove all the white spaces. And so the intention behind this is, for example, a document is a collection of paragraph, right? That paragraph will again has to be categorized, has to be partitioned into so many sentences. That sentences will be again into some words, tokens, and all. So on each and every word has to be converted into a number. Why? Because we are dealing with the text, but machines cannot understand the text. So that is the reason why we need to do all this kind of data pre-processing before we are feeding that input to some machine learning algorithm. So we need to convert into its to the lowest level, that is to the token level. And once we converted all these words into the token level, we need to convert those words into some numerical way of representation before we are feeding it to some machine learning algorithm. So this is about working with the text. So how can we do with how can we do in using in Python? So that's what I am about to show you. Right. So first of all, we are doing some data pre-processing. I have taken some news data set, which is called as news trend data set. So this data set is a corpus. We can call it as a corpus as because it has some 7,000 instances in my particular data set. So I cannot able to load all these 7,000 instances. So for simplicity's sake, what I am been doing in the sense. Means I'm just see if we keep if we are moving. So just wait. Okay, see, for doing some data pre-processing, so we need to import all the important libraries, and moreover, the NLTK package is mostly be required. So this we can able to directly get it from the net, and we can use this NLTK for doing some text pre-processing or text classification, whichever the things that you want to work with NLP. And the pandas environment we require, and moreover, our agenda is to convert that large corpus into some paragraphs and sentences into words and so on. So for doing all these ones, this process is called as a tokenization. So to do this tokenizations, we need to have a class called word token. Right, so this we will get directly from the NLTK. So directly import this one and load your data set. And add the columns whichever you require. Right, so I'm just printing the first 5 rows of my particular data set. Right, so of course it has some 7,000 instances in my new standard data set, but I am showing for simplicity's sake we are taking only the first 5. And the first and foremost thing is, first we need to come to know whether my data set containing any missing values or not. So these are all the available features I have in my particular data set. So I am exploring each and every one whether anything is missing. Why? Because if it is missing, we can able to arrange with some custom value, right? So that is for the sake we are trying to find out whether this title is containing any null values or text or any missing labels we have. So those things we are about to tends to find out, right? So this is how the way we can able to print out. Just call the function is null, and it will return true if any missing things will be there. And then try to print out the count of it, right? So call just the sum function. And once we are clear with this, then we are so the data set can be used, and it is gone for the data pre-processing. In data pre-processing, just now we talked about like we need to remove the punctuations, so we need to convert it to lowercase. If any numbers will be there, that has to be removed, or it has to be converted into some word format. So just for doing punctuations, we are again just reading the data set and then we are printing it. So I am calling, I want to know what punctuations NLTK will handles. So in order to know it, just call string dot punctuation. So your NLTK responds like this. So these are the symbols that NLTK will totally focus us on. That means if these symbols are present in your text, then it can be automatically be eliminated. So like apostrophes, hash symbols like comma or division. So these are some special symbols which on which NLTK will work very good. So now from my particular feature, for example, say I can take some title or text, whatever I require. So I need to remove all this. For example, see if I see in my title, I will have special symbols like this, right? Like semicolons, commas, full stops, and all these brackets, open brackets, and all. Anyhow, this bracket is also considered by NLTK. So these things can be removed automatically. So in order to remove it, I am just writing a function like a remove function, and I am passing each text as my input, right? And so it will check each and every character. So I am taking each and every character and I am considering it whether it is in the punctuation. If it is in the punctuation, if it is not in the punctuation, just add it to the new one, new column, right? So otherwise you need to simply exclude it. So this is a simple function which can able to remove all my punctuations that are present under text or title field. And if no special symbols, then we are simply adding that character to my a variable called text no punctuation, and I am returning it. So so that returned text will be placed under a new column called title clip. So I have just taken this title. See here, hilarious sphere, right? Once we consider this hilarious sphere, this, if you see this a single apostrophe, the single apostrophe is not been included under this NLTK, so that remains as it is. But if I take some brackets like open and closing bracket, that is been cleaned here, and you can see betterly at it, right? So like this, if you have some special symbols there, here and there, apostrophes, this has been get cleaned. So this is how the way we can able to do some cleaning on a particular column, whatever we require. In a similar manner, if you want to work on this text also, the same logic only, just now pass this text as an input, right? That's all, and just apply the same logic over there, and you will find this text clean, and I am appending it to a new column called text underscore clean. So the text underscore clean containing all the text without these special symbols and all, correct? So this is how the way we can able to do my process. And moreover, I told you about tokenization. So it has to be break into, your corpus has to be break into paragraphs into some sentences into some words and all, right? To do this tokenization, what I am been doing in the sense means, I am calling a function like tokenize. I am writing a function like this, and the same logic only the thing is I need to be split. In order to split it, I need to have some regular expressions for it. So this is /w, this is capital W plus. It will treat it as a word and number if it is. Right? If it is a small w, it will consider only word. So these regular expressions, we required a module called regular expression. So import that regular expressions, and using this ARIA object, we can able to split your text into so many words. Word plus, I am talking about word plus. So it will be divided into words. For example, see here I am taken this title text, and this title column has been tokenized into words, individual words like you can smell, like, and so on, right? So each and everything will be tokenized like this. This is how the way we can able to do. I'm just printing the first 5 rows of my particular data set. And moreover, when even if we tokenize also, we need to make ensure that whether this will actually works. Means as per NLTK, the NLTK will tells you that there are a lot of words which are doesn't having any kind of meaning. So in other words, we will call those things as some useless words, right? So it is most important to remove these useless words also. Otherwise, what will happen means my training data set, whichever I am getting as an input to some any machine learning class, where will become very huge. When it will becomes very huge, the time it takes to process, moreover, will gradually increases. So by the time when we are about to fed as an input only, we need to remove all the useless words. So that useless words in NLP, we will call it as some stop words. So these stop words has to be get removed before we are taking the actual words, which will be most useful for a machine learning classifier to get a train. So in order to know which are the stop words, we don't know all. So for that, what I am requesting my NLTK means, I am requesting what are all the stop words that NLTK will consider. So just use NLTK, import this NLTK, and then ask for which are all in English. I am calling in English. That means I am trying to ask my NLTK about the English stop words. That means these are my stop words, what NLTK doesn't focus on. So I'm just printing which are considered as a stop words so by NLTK. So just I am printing only the first 100 stop words. That means if any such word present in your document or a particular column, that will be get automatically be eliminated, so that it will free up the space, right? So just I am asking my NLPK, see these are all like is, as, was, that these words doesn't having much impact whenever we are trying to fed as an input to machine learning classifier. So that's why we are eliminating at the first stage itself. So remove all these stop words. In order to remove such stop words from our data set, again I am writing the same function. and then I am passing each text. And then what I am doing means I am taking each and every word. If that word is not being there in stop words, then simply we can use it. If it is there, means we need to exclude it. So this is the code for doing it. And then I am returning that string text clean. So this is text clean. I am putting in one more new column called title underscore clean underscore stop words. That means after removing stop words, see, so actually these are my tokenized words. From these tokenized words, it is removed stop words. See, U is actually a stop word, right? So that it has been eliminated. Can, so this is also one of the stop word. Like this yes is also one of the stop word. It doesn't play much importance when doing some pre-processing. So after removing all the stop words, so this is the final words which are very important for a machine learning classifier to be trained. Like this, we can able to do on any column as we require, whichever you want, right? And moreover, so this is how the way we can able to do we can able to work with the text in data pre-processing. So next, once this text pre-processing has been over, then we need to mainly focus about the main important topics and the terminologies of NLP. The same thing, the tokenization is one of the important one. Anyhow, we covered in the earlier slides itself. That means the sentence tokenization or some word tokenization. Once we did tokenize, then what we are about to do? So we are about to stem it, stemming, lemmatization, bag of words model, TF-IDF. These are the feature extraction techniques that we need to consider as the basics of the NLP. So we will start about with the stemming and all. What actually stemming is. Of course, anyhow, we have some again the same slide. Sentence tokenization, for example, it is the sentence, right? That means sentence tokenization means it will tokenize up to each and every sentence, right? So this is up to one sentence, right? Wherever we find some full stop, that is considered as one sentence. So like this, it will divide it into 3 sentences. For a given paragraph, it will be divided into 3 sentences like this. And moreover, word tokenization means now on the sentence tokenization, it will tokenize into each and every word. So like this. So when we tokenize it into words, we will find each and every one is one word. And in that words, we will have a plenty of stop words. So those stop words we have to be get rid at the first stages itself. This is how the way the word tokenization is about to work. Anyhow, we have seen about word tokenization. And come to the next important thing called stemming, text stemming. So what do you mean by text stemming? It is nothing but whatever the words that we got from the word tokenization, we need to stem it. We need to stem it means we need to cut to its stem. That means up to its root. That means cutting the suffix. From particular word, either at the front end or at the back end, we are stemming it. That means it can cut either the beginning or the end of the word. For example, say when we tokenize this document, we will get all the words like this. For example, say if I take data, I cannot able to stem it. So that means the NLTK is telling that for data, it resembles the same. But for science, it is stemming. It's stemmed. That means either the first characters or the last characters will be get cut it off. So, for example, users, see, it removes yes, like scientific. It will consider only up to this. So, like this, for each and every word, whatever it tokenized, it will be tokenized into its stem. Why? Because somebody will use this scientific, so everyone can make use of. That means we need to think that most of the people, whenever they are preparing some document, they misspell it as instead of scientific, they may misspell like this, or science, they may be misspell like this, or algorithm, or whatever it may be. Instead of writing algorithms, they may write some algorithm. So in text stemming, it will stem to its root. And then we can able to whatever we stemmed it, this will be taken as an input in the lemmatization process. In the lemmatization process, the output of this lemmatization is a lemma. That means the actual word. So this is the main difference between stemming and lemmatization. Stemming doesn't focus on the actual word, but lemmatization will always focus on the actual word, which actually you will find in the dictionary. So if I write, if various people's like science, if they write like science, sciences, science, and one more scientific, it will, if such words are there, it will, all these such words are been framed into one useful word, which will be actually used in the dictionary. So that we will be carried out in the lemmatization phase. So this is how the way the stemming and the lemmatizations will work. But moreover, anyhow, for doing that lemmatization, the only thing is it needs to consider the corpus of that means the dictionary of the vocabulary of words. From that the dictionary of vocabulary of words, it has to find out the right word for all these words. So that's why lemmatization process is more slower comparing with the stemming. But anyhow, stemming is more faster, as because it will just cut the words either at the end or the beginning in order to try it as a meaningful sentences. So that's what lemmatizations will do. So in the lemmatization, so they had been written like this. The same words you will find. Instead of users, it will, that means somebody will write users, use, whatever it may be. Whatever they write in lemmatization process, it will use as a vocabulary word only. That means that word having some meaningful, and moreover that word will find out in the dictionary. So those things only will be considered in the lemmatization process. This is how the way the stemming and the lemmatizations will work. So when we put this thing into the practical perspective, so this is how the way the stemming and lemmatizations will be carried out. So this is up to this one. So in order to do this stemming, that stemming algorithm requires a predefined class called porter stemmer. So we need to create an object for porter stemmer, and then we are calling the same function that we as well used in the earlier. And then each tokenized word I am passing as an argument. So that means whenever I pass each and every tokenized word as an input to my porter stemmer, that porter stemmer will stems that word to its root, either at the front end or at the back end. Right. So the same logic I applied here, and then see, I will find for smell I got smell, but for Hillary I got Hillary. Instead of Y I got I. That means it will be replaced with another words by cutting it to its root, either at the front end or at the back end. Like this, we will find all the stemmed words of these tokenized words. So this is how the way the stemming process can be done. But if we have a question like this, what can we do? Either stemming or lemmatization is more important for NLTK. Means I strongly support for lemmatization. Of course, it consumes more time to search the vocabulary. It always gives the correct word from the dictionary. So that's why I suggest everyone to go for lemmatization besides the stemming. So this is how the way we can, if you take each and every paragraph, it will be say carry instead of Y they write like this. So Paris, so instead of it they got only Paris, the S has been stemmed. So either at the front end or at the back end, the words will be get stemmed to its root. And moreover, if such stemmed words I got as a collection, now this collection of words in the dictionary, it will have a single word. So if you want to replace that collection of words with a single proper word, then we need to go for lemmatization. So for lemmatization, in the same manner, for using stemmer, here you should use porter stemmer. Here you should use word lemmatizer only, and the same code I am writing here. By this time, the input that we are passing is a stemmed word, right? So that stemmed word I am passing as an input to my lemmatization function, and then that lemmatization word will again correct all that words into some meaningful words. So that we will find over there. Of course, my window doesn't fit the screen. So you can able to find out all these lemmatized words. If I right. So this is how the way the lemmatized words that we got it. Right. So this is how the way the lemmatized words we got it. That means the correct words that actually finds in the dictionary. Those things only we are about to your machine will be considered instead of stemmed words also. So that's about the process of stemming and the lemmatizations. So only the difference is lemmatization will write that word to its base form, whereas in stemming words it will remove either the first word or the last word, or that means it will maintain each and every word in the form of some suffix. So that suffix some machines will understand, some machines won't understand. So there is a huge requirement for converting that suffix words into proper words. To do that into some proper way of representation, lemmatization will works better. And moreover, it is slower when comparing with stemming, as because it needs to refer the vocabulary, that means the dictionary, in order to find the exact word and the correct word for predicting out. Right. This is about the lemmatization process, and moreover, we have seen those stop words. And the most important topic in vectorization. Without vectorization, NLP, there won't be the concept of NLP. So we know what is a vector. Before that, we know what is a scalar. A scalar will have only a magnitude, right? That's what we know. But a vector will have both the direction as well as magnitude. In NLP, this vectorization is the most important concept, and why in the sense means that's what I told you in the beginning. For example, say in vectorization means we know vector, right? So it is a group of some words that may have some variable length. So it cannot be defined at the beginning. It can be varied. In vectorization, what we will do in the sense means whenever we plot all these words. Why? Because what is our goal? Our goal is now we converted all that words into some meaningful lemmas. Now that lemmas are the most important words, that lemmas has to be fed as an input to some machine learning classifier. But we know that machines cannot understand this text and all. So we need to have some conversion from text to numbers. To represent the text to numbers in NLP, there is a concept of this vectorization. What is this vectorization means? So if we plot, what we will do in the sense means we will consider each word as either a 0 or 1. If it is present, we will be replaced with 1. Either it is similar like one-hot encoding. If we do one-hot encoding, the length of your vector may increases gradually. So when it will be increases gradually, and if we try to plot it on a graph, definitely all that vectors won't be in one direction. It may be scattered around here and there. That means it is very tedious to find out the directions of the vectors. If I have some feature space and if we plot all these vectors, we will get some n feature space vectors. So understanding these n feature space vector to any machine learning algorithm again will be a complex one. So what we are doing means we are making all that one-hot encoding in the form of some vectorizations. In vectorizations, we normally use two types of vectorizations. One is called as counter vectorization, or other one TF-IDF. This counter vectorization can be attained through some back of board model. Using a back of board model, we can able to attain this counter vector, and later we will have some TF-IDF vector. We will see the differences between which vectorization will works very fine when we are fitting as an input to some machine learning classifier. So what is first of all, make ensure that what is vectorization. For example, say I have a document like this, a paragraph stating like this: the elephant sneezed at the side of potatoes. For example, if I want to represent this sentence in the form of some vector, what I need to do means, first of all, I need to arrange the words in some ascending order. Like for example, say A will come first before B, right? In the same manner, I will go up to some W. And if any that word is presented, I will put 1 over there, and the remaining cells I will mark it as 0. So for this particular paragraph, see my vector taking this much infinite length. So if my paragraph, if my sentence size will grow dramatically, definitely this vector size also will grow automatically. So this is how the way the vectorization can be done. So for the same case like this one, wherever you will find that particular words, we will replace with ones and zeros somewhere. So for 3 sentences, if I get 3 vectors. So in the so now all these 3 vectors has been converted into numbers now. So this is the main goal of converting words into the number through this vectorization. So for doing this vector encoding, 2 types of encodings we are about to popularly there. One is called as counter vectorizer or bag of word model and TF-IDF. For example, say this is so it is one of the simplest model. If we take counter vectorizer, so what it will do means it will just compute the frequency of the words in the particular document. I am considering this one is one document. Actually, it won't be a document, it is a sentence. You treat it as some document. So you just compute the frequency of the words that are happening in the particular document and then do this vector encoding. So for example, say if I take this first document, wherever I finds I is eliminated. Why? It is a stop word. So in the data pre-processing phase only, we will eliminate all this one and only we will take only the unique words. So from all these 4 documents, just take the unique words only. That means what? From all these 4 documents, of course, this and this appears twice, but I should consider only once. I like also appears to duplicated it, so I will consider it as one only. But so these things will represent you the document number and which words present in this particular document you replace with ones and zeros. So that's all. So in the similar manner, if a particular word appears twice, then I need to increment it. So it is the simplest one. If word exists, then I am replacing with 1. If that word won't be present in the document, I am replacing with 0. So for 4 documents, this is my vector. For 4 vectors, I got it. This is the counter vector or the bag of words model. In the similar manner, we will go for TF-IDF. Before going to TF-IDF, we will see how this bag of words model will work on the lemmatized text. So to use this bag of words model, simply again count vectorizer is a class that you should import it from SQL and create an object for it, and then I am calling what are all the features. So see from my data set, so it has some 10,071 columns it has, and moreover these are the number of rows that are present. That means the instances. So each instance is considered as one document. So that's what I do. So if you just look it out, I am just calling out all these are all the features. So from all these features, which are all the most important features, so that is our goal. Why? Because these features only we are about to fed. Before we are feeding that data pre-processing, we think that data pre-processing, stop words removal, punctuations, anything. If we have everything will be cleared, and we are just printing it. So I am just printed it. What are all the available features, and then I am printing into some bag of words model like this. So when I print, I have given some range. Why? Because there are plenty of words up to some 7,000, right? I'm just printing some subset of this. So if I for the sake of seeing only, I have did like this. So just I'm taking all the feature names and then I am transforming. So these things will indicate you the documents, and why? Because I have taken only 10. So 3,920 to 3,930. That means I'm collectively taking only 10 documents, and from these 10 documents, how many features I have? It is around some 10,000. It is showing. So all the features I am been presenting like this, and wherever that word is presented, it will be marked as 1. And the remaining that means, for example, say if I take the 08th document, these features features may not be present. If I take first document, I got, of course, I don't find any more word. If I take the second document, absolutely presents only one type. So that's what its meaning is. In the similar manner, I am about to print all the bag of word models like this. So it is a 10 row into 93 columns. So we got it. This is how the way. But what can we infer from this bag of words model means we infer that, for example, say we inform that if all the entries are zero, that means that word doesn't having much uses. Of course, it is removed from the stop words only, but even if it is not a stop word and if it is entered into some bag of word feature name, if it is having some less weightage, that means from this we will confirm so that that feature having less importance. If more number of words you find, then you consider, for example, if you see Trump here, Trump see out of 10 documents, 3 documents are supporting Trump. That means I will come to a conclusion that this word is most important. Why? Because it have 3 weight. But if I take some other things like we, it have only 1. It have only 1. That means this feature vector may not be important. And so in this manner, so bag of words model will simply take its weight into the consideration, and it will let you know how important that particular attribute is, whether it is important or not. So if more number of ones we will get for that particular column, we infer that this feature is most important. Otherwise, we will consider that this feature is very less important. So this is how the way the bag of words model will works on. And what is the major drawback with this means the major drawback is its behavior. So it will take only the words which are having higher weight, but it doesn't focus on the lower weights of the words. So that is the major drawback with the bag of words model. So that is the reason why we are moving into TF-IDF. So this TF-IDF will not only focuses the most weightage word, it will always focuses the less important one also. Besides the most important word, it also focuses the less important one. So we know all this. What is TF-IDF? It is a term frequency with the inverse document frequency. The name itself it will tell you. Using this TF-IDF, we will come to know that how important a particular word is. In simpler sense, what I can tell means count vectorizer will works only on the more weightage words, but TF-IDF will works on the less weightage word. Why? Because the less weightage word will have a special meaning, so that we are ignoring those special meanings in the count vectorizer. So that is the reason why we are jumping from count bag of words models to TF-IDF model. So it will take the TF weighted term as well as the IDF weighted term, and then we are multiplying it. So whenever we multiplied it, when that weight will becomes more, if these two terms weights are very more, then its importance is very good. If any one of the IDF term becomes 0, that makes a confirmation that this word doesn't have is a significant impact. So this is how the way we can able to do it. So how can we compute this TF term? Means it is been defined like this: how many times that particular word appears in a document divided by the total number of items. That means here the items means the unique items in the document. So this is how the way the TF term will be computed. So for example, say if I take the same document, if I take a particular word like, so I want to compute the TF value. So I need to compute using the formula how many times this like appears in the document. How many times this word like appears in the document divided by the total number of unique like items in the document. For example, hello sir. Hello.
Sir, tell me, sir.
I'm getting some disturbance.
Let me check, sir.
ఆ రికార్డ్ బుక్స్ తెమ్మంటే ప్రాజెక్ట్ అంతేగాని మనకు ఉండాలి మళ్ళీ ఎప్పుడైనా ఇన్ఫెక్షన్ చేసినప్పుడు పక్కన పెట్టాలి. వాళ్ళు అడిగారు ఇప్పుడు సైన్ పెట్టేసి ఇంకా దొరకలేదు. నోటీస్ వచ్చారు. ఇప్పుడు సైన్ పెట్టేవాళ్ళు పోయి కథ మా బుక్ లాంటి పోతే మన ఇన్ఫెక్షన్ అవుతాం.
Sir, please continue, sir. Now I muted
For
him.
example, yes, thank you, sir. I want to compute the frequency of that particular word, like say like. So as per the formula, it is 1. Why? Because the number of times in this particular document the like is occurring, that is 1, and how many times this the same term like appears the whole document in the whole corpus, that's 2. So it is 1 out of 2. So your TF weight will becomes 1/2. And moreover, inverse document frequency. So here also the same thing. So total number of documents, so is nothing but 4 items as per our example. And moreover, how many times that term appears in the particular document. So 2 times it is appear. So for 2 out of 4. If we multiply these two, we will get some weight value of the particular document. So the more the weight value, the more the TF-IDF you will be getting. So this is how the way the TF-IDF calculations can be done. And moreover, once we calculate all values, we are computing the, just write the mathematical formula using Python, and then just divide it and then multiply it. So we will come to know that so these are the various weights of each and every word in TF-IDF. So when we got these weights, you just check it out which are having more weight. So these weights are having more, for example head, and this 0.5, 0.5, these things having some higher weights. And you consider the words which are having less weight. Why? Because those less weights indicating that a few people only are talking about on that particular word. So that is the special word and most important word in all the documents. So one should focus on such words. If we find out such important words and we collected it in some particular document, and we can able to fed it as an input to some machine learning classifier, so that it works very fine comparing with the backup words model. So if you compare with all this, see some words like this 0.3, these words having some less weight, like here. So these words having some special meaning. So those things we should be taken care into the consideration. This is how the way we can able to compute this TF-IDF. To compute this TF-IDF in Python, again it is very simple. So only the thing is we need to import in backup words model. We are importing count vectors. Here we are importing TF-IDF vectorizer and just create an instance for this, and then just I am first of all calling all the feature names. So the same feature names whatever we got in count vectorizer, the same things it will sure this many number of documents we have and this many number of columns have, and you will find various numbers on them. So numbers we should eliminate it. That's what we told you. If any number is there, that has to be get eliminated in the beginning itself. And then we are counting, we are finding out the TF-IDF scores of each and every board. And I'm taking some sample of 10 records again, 10 documents again, and then I am training it, and then I am printing it. So from this, I got various weights of each and every board. From this, I make the conclusion that only the document is one is talking about this feature. Only the document 3 is talking about this feature. So which features are most important means it depends upon the weightage. So we can able to find out some threshold. We can able to ask some threshold, and we can able to know the conclusion of which items are most important,
Chaudhapa sir,
least important. So this is how the TF-IDF vectorizations can be done. But moreover, both having drawback, why? Because our vector sizes will grow actually. In case of count vectorizer, we will get a large space matrix, right? But in case of TF-IDF, we are also getting a large vectorization, large vector. But in TF-IDF, we are also getting the same, right? So we need to work on it. How can we simplify that large vector into some shorter one? For this, we will have various other kinds of feature extraction techniques like to vector. So all these are word embedding techniques only. So if we want to move further, word to vector will work so very fine. When go to vec is incorporated, it can remove this large space of vectors into some smaller space, so that space is minimized, and moreover, if space is minimized, then we can see some enhancement in the running time of the algorithm also. So this is how the way we can able to calculate the TF-IDF and bag of boards vectorization process. So this is how the way we can do it. And moreover, so we did some extraction, creations and all. So for my purpose, this is how the way we were able to do the vectorization process. Next, when moving with the TF, yes, yes, yes. చెప్పండి సార్.
Sir, you are not audible, sir.
Sorry for the interruption. Did you have some technical problem? So, am I audible and visible? My screen is visible.
Yes, sir.
Am I audible? Can someone respond me?
Yes, sir. Sir, your screen
Chodappa, you are audible.
visible, sir.
Yes, sir.
Yes, you are audible, sir.
Chodappa,
Hello, sir.
hey, you are audible, Chodappa. You can continue
Am I
your.
audible, sir?
Yes, you are audible. You can resume your presentation.
Audible.
Chodappa,
Hello.
hello, Chodappa.
Hello, sir. Am I audible? Huh? Hello. Am I audible, sir?
Hello. Hello. Am I audible? Oh, okay, sir. Sorry for the interruption. We have some technical issue.
Am I audible?
Coming to the next one. Coming to the next one. Coming to the next one. So the purpose of TF-IDF vector is to find out the least frequent words which are most important for a machine to train, right? So that is the purpose of TF-IDF. Here we are just calculating the TF and IDF scores individually, and we are multiplying it. All right. So next we will be move on to where NLP can be used. Next slide. So where NLP can be used? NLP can be used both at classification and regression tasks. NLP can be used both at classification and regression task. So I will just tell you how we can use it in some classification. Here we are considering the same data set. Our intention is to fed that data set as an input to some of the classifiers, and we are about to trace out this data set in detecting some fake and real names, right? So for this, we are importing all the needed libraries, so which we required. We know all this train and test split for training and testing, and we use a concept called pipeline here, and we use two of our feature vectors, vectorization techniques like count vectorization and the TF-IDF, and we are about to generate some confusion matrix. And we have some classifiers like logistic and linear SVC and multinomial. So we will see how these will work on these classifiers for training and predicting out the accuracy. So first, as usual, we know we are reading the data set and we are just shaping out, right? So we are first filtering the first 5 rows. And then we are just in classification, we have to know the label, right? So we are checking whether labels are there or not. So the next thing is we are splitting the database. So when we split our data sets, we are giving what can be the test size and what can be the train size, and these are all the labels for training and testing it, right? And moreover, we are using the concept of vectorizer and the TF-IDF, and these two feature extraction techniques I used on my data set, and then using the features it extracted, that will be fed as an input to these classifiers, logistic, linear SVC, and multinomial. Right? So in order to do it, we require TF-IDF Vectorizer. So this constructor uses one parameter called maximum. It stands for document frequency. Maximum document frequency, what it can be. So if I tell 0.8 in the sense means, so this maximum document will ignore those items that appears in more than 80% of the document. If I consider in my corpus 100 documents are there, 80% of the document, 80% of the document, if it contains some stop words, I am about to ignore all this. So this is the meaning of it. Even in the same case of MinDF also we will have. So that MinDF will tell you the infrequent items in the document. It is just opposite to that of MaxDF. And then we are fitting it. That means we are training it. So training in the sense means we are making our machines to learn, and then we are testing it. So now using these vectorizer and TF-IDF features, now we will fed these two feature extraction techniques to one of the classifiers. For example, we are first considering the first one called logistic regression. We will talk about it. So how in Python we can able to perform some actions at a time using the concept of pipelining. So in case of pipelining, if you use pipelining, what pipelining will do means it will combine these two feature extraction techniques with a classifier. That means these two will act as an input, and whatever the classifier that we are using, that will be act as an output. So here, see, this pipeline, I am writing it as these two acting as an transformers, and this one will act as a responder, right? So I am taking some logistic regression. So we all are familiar with how logistic regression will classifies fake and the real news. So it will maintain some threshold. If it meets that threshold, it will consider the fake news. Otherwise, it will consider the real news. So in order to do this, what I am doing, just I am creating an object for it, and then I am training it using this classifier, and then I am predicting it. The predicting variable, I am calling it as some LR underscore pred. Once I got this LR underscore pred, using this LR underscore pred and this y underscore test, I am building some confusion matrix. So once we got that confusion matrix, we can able to find out the accuracy, right? So using some precision recall and calculating F1 score, we can able to calculate the accuracy. So when I use logistic regression on the same data set using these two feature extraction techniques, I got the accuracy of that logistic regression classifier is about some 91.5. So this is how the way the confusion matrix is been built, and the accuracy I have been calculated. So we know the confusion matrix how it. So this is about confusion matrix. So we will have true positive and true negative instances here. Taking these things will call recall, and taking these two things will call precision. When we multiply these two, we will get the accuracy. So if we see this one, the number of that. If we see this value, that FP and NP values are very less, that means our model is somewhat good as because it is giving the correct results. We get the correct. So this is how the way the precision recall will be calculated, F1 scores will be calculated. So this is so anyhow the accuracy that I got from logistic regression using those two feature extraction techniques is around some 91.5. And if I use some different classifier like multinomial NB, so maybe this. So if I use this and the same code I did it, and I calculated, I built the confusion matrix, and then I calculated the accuracy. So using this one, I got 81.6. So it is somewhat lower comparing with the logistic regression. And so the same one I did on linear SVM. If I use this linear SVM, I got an accuracy of 92.58. So what these things will indicate to you means on what kind of data sets, which kind of classifiers will giving a good accuracy. So which is the best classifier for classifying some classification tasks like sentiment analysis or some detecting some fake news. So which classifiers will be very good? Of course, comparing with the linear SVM, random forest and all, using some ensembling techniques also, we will get a good accuracy measures comparing with it. For the sake of simplicity, just I am showing you how can we do classification task on the textual data. So that's what about how can we do use the feature extraction techniques, and how can we apply those feature extraction techniques to find out the accuracy of the classifier. So that's about the code regarding it. And coming to these slides, text lemmatization. So these things we covered. I told you also NLP can be applied both in classification and clustering. So we know what classification and clustering are. So mainly in NLP we can use it for sentiment analysis, and these are some of the classifiers which will works on the classification on the textual data, and moreover clustering. The LDA is one of the powerful technique where we can able to cluster some things. See, not all the times we'll get the labeled data set. Sometimes we need to find out the label, and then we need to perform some classification or regression. By that time, LDA, it stands for latent distillate allocation. That means latent means hidden things. That hidden things has to be try to find out, and we will consider those hidden things as some labels over there. Whatever the labels that we extracted, we need to apply some probability. Distillate allocation means we are assigning some probability of the extracted topics, and then we are allocating it to some clusters. So LDA is one of the clustering techniques, and most of the research is going on LDA also. And if we see how classification pipeline will works in NLP, it is similar like the usual case. The training and test data we will give it for training the classifier, and then we are giving some text data. Besides this one, we are including the feature vectors. That means we can use any count vectorizer or TF-IDF besides with the training data. So that was the difference that you should observe when we are working with NLP. And when you come up with the LDA, that means classification techniques, here also the same thing. But in classification, we don't have some labels. No? So first thing is we need to find out that labels, and we assign it to some different topics. For example, say if I have a paragraph, that paragraph may include so many most useful words and less useful words. Some words will related to a particular topic called some sports. Some words may related to a particular topic called some entertainment or news or something else. Like this, you should categorize into different topics like topic A and topic B and topic B. These are the clusters. Once we got these clusters, then we need to apply some similarity metric. So using this similarity metric, we will come to know that how one topic is been interrelated with the another topic, so that we can able to adjust, combine into some separate clusters. This is how the way the LDA process will work. Here also the feature vectors also will come into the picture. The same thing we can able to apply. So this is how the way the classification and clustering process will be happen in NLP. And moreover, come to with the NLTK, there are some pros will be there using NLTK. These are the two suggestible books that have good documentation over there. And moreover, you will find Python code in these two books for doing all these pre-processing tasks and applying those feature extraction techniques to fed as an input to some classifiers and work on it. And moreover, these two books are mainly designed for training your models and all, and it includes a lot of data sets. There you will find the link where we can find all these data sets. That means the corpus, and moreover, many algorithms will be there to experiment it. So this is one of the good thing that we can know from NLTK. And what is bad from NLTK means it is not suited for big data and all. And moreover, it is not doesn't have some latest algorithms. Moreover, active learning algorithms. So whichever the algorithms we have so far with the NLP, we need to use it, and we need to adjust those algorithms as per our convenient way to find out some accuracy or some performance of a classifier. And the awesome points are nothing but it is very good for research. So it doesn't take too much difficulty for understanding the data sets and all. And moreover thing is, most of the portion you need to be put on some pre-processing and all. And you will find a lot of communities also there. You people can communicate and can do research over there. And moreoverly, all the algorithms are trained, and you can able to span to our human languages. And even using NLP, we can able to do research on our native language called Telugu. We can work on it. Like now we will find all the words which are the stop words related to English. So if you want to work with our native languages, then we need to tend to find out the stop words related to Telugu or any languages as you like it, like English or Urdu, Hindi, or whatever it may be. So you can work in your own native languages also. So those are some awesome points that you should understand it. And most importantly, this slide will tell you how NLP is, so how easy it is. See, we have only 3 classification algorithms, and we have POS 9 tagging algorithms over there. For stemming and lemmatizations, a very few. And moreoverly, the data sets also very limited, so you can work on the public owned data sets. No need to look for some other data sets or doing your research. And coming to, these are some of the references I followed for NLP. So thank you.
Thank you so much, sir, for your session on NLP. Hope the session was quite informative. Participants are requested to join for afternoon session at 2:30 p.m. Thank you.